This video is on section 4.4. It's going to go along with number 27, homework. We're looking at properties of logarithms. In the next section, we will be solving logarithmic equations, and we'll have to know how to manipulate these logarithms to do that. There are three properties for logarithms that we need to remember. Now remember, a logarithm is an exponent. So you're going to find that when you have one log with the argument being multiplied, it can be split into multiple logs, separated out. And remember, when you multiply with the same base, you add exponents. So you need to associate multiplication with addition. Then you're going to see where you have a single logarithm with an argument being divided, x divided by y, you can separate that out into a subtraction. Now remember, when you divide exponents with the same base, you do subtract. So remember, there is an association between your properties for exponents and your properties for logarithms. If you have an exponent raised to an exponent, if you remember, you multiply. Well, here's my logarithm, which is an exponent raised to an exponent. And if you'll notice, you're going to use this exponent as a coefficient multiplier. Okay? Now, these three rules you just need to remember as we go through here. Your MyMath Lab assignment is going to first give you one log and ask you, I think they're going to say express it as a sum, such as this one, or a product, or a difference. Sometimes I'm going to say just expand it. In other words, take one log and make it several logs. So let's see what we can do with this. Number one, if I have log base 8 of x times z, now notice you see multiplication there. So what I'm going to do is have log base 8 two times, one for each factor, x and z, and because I see multiplication, I'm going to add the two logs. Now one will be log base 8 of x, the other log base 8 of z. Now remember, this 8 is a subscript. Alright, number two, here's our second rule. You have a division going on in your argument, and when you divide, you subtract exponents. So we'll have log base b m minus log base b n. Whatever their base is, that's what you use. Number three, log base 3 of x to the fifth. I see an argument here that has a power. I see a power exponent that has a power. So this exponent is going to come out in front. So that will be 5 log base 3 of x. Now that's an example of each of the three rules. Now we're just going to practice with some problems. Number four, the first thing we need to do, remember, is to get rid of a square root. Square root of x would be x to the 1/2 power. That goes back to your lesson on terminology. Now at this point, I see property 3. I see an exponent that needs to be brought out front as a coefficient multiplier. That will be 1/2 log base 2 of x. Number 5, you're going to begin seeing two rules put together. I see a product, and each of those factors has a power. So first you're going to have log base 3 of x squared. Because of multiplication, let's go back up here. This should have been division. I'm sorry, I just looked up and saw a mistake. Division associates with subtraction. Now, because of this multiplication, I'm going to be adding. So this is going to be log base 3 of y to the 6. Now I have another step to simplify here, because I have these exponents that can come over in front. So we will have 2 log base 3 of x plus 6 log base 3 of y, and that would be complete. Alright, another one just like it. The only difference in number 6 is that we're dealing with natural logs, ln, but you just use whatever your problem has. So we'll have natural log of x, there's a product, so we add, natural log of y squared, another product, we add, natural log of z cubed. Now we need to bring our exponents in front, so we'll have natural log of x plus, bring the 2 over, 2 natural log of y, bring 3 over, plus 3 natural log of z. Alright, number 7 has a cube root in it, so the first thing we'll do is to get rid of that. I'll rewrite it as log base 7 of x over y to the 1/3 power. Now let's think first of all, what would you do with this 1/3 exponent? Well, it will come out in front. Then I have division, so I'll have log base 7 of x minus log base 7 of y. Now that is fine. Another way of writing that would be to distribute the 1/3, which would be 1/3 log base 7x minus 1/3 log base 7 of y. Number 8 looks a little bigger, but it's really not. We have a product, we have a multiplication, and each factor has a power. So first we have log base b of x plus 5 to the 3rd, multiplication, so we add, log base b of x minus 6 to the 4th. Now we're going to bring our exponents in front, so 3 log base b of x plus 5 plus, bring the 4th over, 4 log base b of x minus 6. Okay. Problem number 9 has a natural log, and that's okay. The first thing I'm going to do is to rewrite it without the square root. So that'll be x times x squared plus 1. Now square root means 1/2 power. Now I have multiplication going on here, so I'm going to add. That'll be natural log of x plus natural log of x squared plus 1 to the 1/2 power. Now remember that because of this exponent, we need to rewrite again and pull that exponent in front. And we have natural log of x plus 1/2 natural log of x squared plus 1. Now this is section 4.4. We're converting one single logarithm into sums or products or differences of several logarithms. We're expanding.